Okay, so the unit matrix then. This is basically the matrix equivalent to the number 1. And we call it I, which stands for the identity matrix. Or the unit matrix. And it's just I equals 1, 0, 0, 1. So that leads us on to the inverse of a matrix. So the inverse of a matrix A is A to the minus 1. And if we multiply A and A to the minus 1 together, we get the identity matrix or the unit matrix. And we can do it either way. So A times A to the minus 1 is going to be the same as A to the minus 1, the inverse times A. And that gives you the identity. And to find that, if A equals A, B, C, D, then the inverse A to the minus 1 equals 1 over the determinant of A, which we've already looked at. And now we swap round the A and the D. So the D comes up here and the A goes down here. And then we change the signs of the other two. So that becomes minus B and minus C. So example 10, finding the determinant of, or the inverse of A here. First of all, we'll find the determinant of A. So that's 5 by 3 minus 7 by minus 4. So that's 15 minus 28. So we get 15 plus 28, which is 43. So our inverse is 1 over the determinant. And now we change around the 5 and the 3. So the 3 will come up to the top and the 5 will go down to the bottom. And we change the signs of the other two. So 7 will become minus 7 and minus 4 will become 4. B, then we're going to find the inverse of this one. So the first thing we do is find the determinant of B. So that's minus 3 by minus 3 minus 2 by minus 5. So that gives us 9 minus 10, which is minus 1. So the inverse then of B is going to be 1 over minus 1. And then we'll change around our minus 3 and our minus 3 now the same. So it just stays minus 3, minus 3. And we'll change the signs of the 2 and the 5. The minus 2 and the minus 5 will become a 2 and 5. Now we've got 1 over minus 1. So that's just minus 1. And the last one we didn't multiply in the number in the fraction on the outside of the bracket because it would just be too awkward. But when you have something like minus 1, you can. And we would change it to that. Now, not all matrices have an inverse. So show that C here has no inverse. So start as if you were trying to find the inverse by getting the determinant. So it's 5 by minus 8. minus 4 by 10. So that gives us minus 40 minus 40, or minus 40 plus 40, which is 0. Now, if you went to write the inverse of C, you'd have to do 1 over 0 times our minus 8, 4, minus 10, 5. We can't do this, okay? So we can't divide by 0. So we say there's no inverse.